Hey everyone, we are back today and we'll be covering the periodic table. This will probably be the most important topic you cover in the entirety of Gen Chem. Why, you might ask? Simple. It comes back in every single chem. Gen Chem, OChem, PChem, and even Biochem. So then you might ask, what is the periodic table? And this one's also simple. It's a thing hanging on the side of your classroom, a list of all elements organized in a very special way. Now, the goal for today is to understand the patterns of periodic tables and understand ionic compounds as well as naming some formulas. Now, let's start out with the terminology. This is a pretty basic periodic table provided by the ACS. We like to call the rows periods and the columns groups or families. Now, rows are organized by atomic number. This is basically the number of protons, while columns are the valence electrons. We won't get too much into valence electrons just yet, but basically valence electrons are the electrons on the very edge of an atom. Now there are two types of numbering schemes for columns. One's pretty intuitive, 1, 2, 3, 4 till 18, while the other is by numbering valence electrons. Now the middle part here really doesn't come into this numbering, so rather we do 1, 2, ignore all of this, 3, 4 till 8. Now you don't want to stress too much about numbering, it's just something you'll see, not much to learn there. Now let's look at how to navigate this table a bit. Starting over here, we got column 1, alkaline metals. Now hydrogen's a bit of an exception to this alkaline metals part. It's there because we usually want it because of having 1 valence electrons, but in general, it's not similar to these things at all. Column 2 is alkaline earth metals, this big chunk in the middle that we skipped in the valence electron numbering, transition metals, highly variable properties, not really a set pattern. This blue sort of part below the gray, these are basic metals. This grayish part, semi-metals, basically a mix between a metal and a non-metal. Pink here is non-metals, light blue is halogens, which will be covered a lot. And the final row, noble gases. They don't like interacting. Now these two bottom thingies, yeah, you won't really see them a lot in Gen Chem, OChem, so you don't really need to know them for the sake of Chem right now. Now let's look at ion patterns. This part helps a little bit with understanding the last video, so here's how it works. Different atoms over here try to be different ions. So for this first column here, +1. These atoms are usually inclined to have a +1 charge. The one right after, +2. The middle part, huge chaos, could be any charge. Your teacher might ask you to memorize a couple, there's no pattern, you just want to commit them to memory. Now, the last part, the periodic table, let's go backwards. Last column, noble gases, 0 charge, halogens, -1, oxygen family, -2, nitrogen family, -3. Now, carbon and boron families are a bit random, so don't hold it too much. Now let's look at one general trend. We'll go over many more in the future, so don't fret, but let's start out with something simple with metallicness. We got metallicness, simply draw a diagonal line like this. This shows the most magnetic trends. Anyways, so that's the basics of the periodic tables. Let's cover the formula naming and ionic compounds. Now, the next video after this one will cover the names in English, so for this video I want to cover writing the formulas. The way to write formulas is pretty simple. Just write the symbol of the element, the first letter would be capitalized in that, and if it has a second letter, that one's lowercase. And put the elements in order of their rank on the periodic table. So, let's say we want to write 1 carbon, 1 oxygen. So carbon is basically C, oxygen's O, and so we draw it CO. And if we want to do that with silicon, silicon's Si, see the second letter would be lowercase, and then we just add O at the end of it, which would be capital. Now for multiple atoms, we want to use something called subscripts. So 2 hydrogens, 1 oxygen, we get H2O, which, as you probably know, is water. We can also use subscripts to group atoms like this. These are 3 NO molecules. Net charge, we use superscripts. So lithium ion is Li1+. Now it's important to know that we don't write charge after each atom in a molecule. We write it all at once as a net charge. So in the case of CH3COO, we would write a 1- at the end. So in summary, subscripts are the number of groups, while superscripts are the charge. So let's end this with predicting ionic formulas. Let's say you want to create a neutral charge of a compound with sulfur and sodium. So sulfur, as we discussed in the periodic table, is -2, and sodium's +1. Neutral means 0, so we need sodium 1 sulfur. And we write it like Na2S. Anyways, that's all for today. Take care and good luck studying.